Welcome to Introduction to API Security Landscape with Traceable AI's Head of Security Research, Inon Shkedy.
Thank you, Dan. And hi, everyone. Thank you so much for joining us today. This webinar is dedicated to introduction of API security. I'm going to talk about APIs in a very high level, explain a few different concepts in API, and then jump into a few different types of APIs, and also talk about OWASP top 10 for APIs, and show a few examples for API breaches from the recent time. So one of the first questions I want to try to answer is, what are APIs? Many people use this term, and many companies trying to sell solutions related to APIs, but not everyone understands the definition of APIs. And it makes sense. APIs is a very abstract concept, and there is no one way to define it. Even between developers and engineers, there is not always an agreement on what is an API. So let me share with you a very high-level definition of APIs. API is a tool to expose data or a function from one component so it can be used by other components. I know it's very high level, but the reason is because APIs are also very high level and abstract. I want to give you like a nice example from the real world, how a company can expose an API. So try to put yourself in the shoes of a founder of a company in the Bay Area, in Palo Alto. So you'll basically have a cybersecurity startup, and after you're working really hard, you sell it for billions of dollars, and you become rich, become really rich, and you're happy. And the next thing that you want to do is to buy a house in Palo Alto. You think it's a nice place, you want to raise your kids in this a nice little town. So you go to the rental agency, and you do something very simple. You ask the agent, what is the price of one of the houses? So basically you saw a few different options for different houses, and you really like the one on Middlefield Road. So you ask the agent, what is the price of the house on Middlefield Road? By the way, Middlefield Road is a nice street. I used to live there for about a year. And then the agent tells you, oh, we actually have a really good price for you today. It's only $5 billion. And so you're saying, okay, it sounds like a good price, but I'll try to be a smart consumer. I wouldn't buy right away. I would come back to the agency a few times. So what happens, you end up for like a week or two, you come every morning to the agency and you ask the same question. What is the price of the house on Middlefield Road? And unfortunately, the price doesn't change, but you keep coming to just check the price. And then, after a few weeks, the rental agency says, okay, it's not a good use of our time. It's not a good use of your time. As the founder of the startup, you're probably very busy. We should find a different way to implement this communication. And the way that they do it, they just transfer the same communication. As you see here, you basically ask a question, you get a response from the agency. So they just transfer this communication to the API world. So they build an API, and they also have a mobile app that allows you to communicate with the API. So instead of coming every day to the agency, you can basically browse your app, the real estate app on your iPhone device. And once you click on the house that you like and you have the button of get price, there is an API call to get/houses/717/price. And this is the question that you want to ask. What is the price of the house on Middlefield Road? And the nice thing about APIs, they basically provide you a structure in a very standard way how to ask questions and get responses from the API to get answers. So I want to talk about a few components in the API call. This is basically the API request, right? The get component. This is the API call. This is your way to ask a question. And the first component you can take a look at, it's the HTTP method. So in this case, it's a get HTTP method. And the HTTP method is a way for the client to tell the API what type of action you're going to perform. In the case of get, it basically means I just want to fetch data. I just want to get it. I don't want to change anything, just like look at data. So for example, if you scroll your Instagram feed, you'd perform a bunch of get API calls to load more items for the feed. Because when you scroll the feed, you don't change anything. You don't update the status. So the same thing here, because you just want to get the price, you just need to ask a question of get, just to fetch data. And then you can see the URL /houses. Houses is the resource that you want to access. Resources is also a very abstract concept in APIs. A resource can be any type of information. So for example, in the case of Facebook, if we talk about different resources that their API exposes, it could be a post, it could be like a comment, everything can be a resource. And then you can see as part of the URL, you have this number, 717. So what is this number? Basically, it's a way to represent a specific object that belongs to the resource that came before it. So it means I want to access house number 717 and to get its price. So this ID, basically the ID of the house. It's a very intuitive way to represent different objects in an API because the rental agency has probably many properties and you want to ask for specific ones, so you need to mention the ID of the house. And then the response from the API would be also very intuitive. You can just take a look and understand that the price is the parameter name and the $5 billion is the value. So what you can see here on the screen is basically how API makes communication very standardized. It creates a very easy framework for developers to ask questions and to perform different functions on a remote server using APIs. And there are different types of APIs. There is not only one standard, but the most common standard today is the REST API. And I want to talk about a few other concepts when it comes to REST APIs. The first one, we talked about get HTTP method, which means to get information, but there are also a few others. So on top of get, you can find put or patch, the same thing. It means that you want to update a resource or to update something. So for example, let's say that you comment on a photo on Facebook, but then you decided you actually want to change what you wrote. So once you click edit on this comment and you edit the text and you submit the new comment, there would be an API, a put type API call behind the scenes to the change comment content on Facebook. And we talk about post, it basically means to create something new. You want to create a new object on the API. So if you upload a photo to Instagram or to Facebook, it would be a post method. And last but not least, you have the delete HTTP method, basically means to delete something. So if you commented something and you want to completely delete the comment, you can click on it. The API call behind the scenes would be delete. And the second concept I want to talk about is API endpoints. So API host is a bunch of different endpoints, and each endpoint represents a different action that you can perform on the API. So we talked about the get price endpoint. It allows you to get the price of a specific house, right? But maybe after the agency exposes the API and it sees that it works pretty well, they want to start exposing more functionality from the same API host. So they would build the contact us endpoint. And then you would have an option from your mobile app to send a complaint or like a feedback about the app. Behind the scenes, there would be an API call to contact us endpoint. It would be probably a post HTTP method because you create something new. You create the complaint or the feedback. And then also they might want to automate the transaction process. So you can buy a house online, you can pay the $5 billion online. So they would expose a different endpoint of buy house endpoint. So it's important to understand that modern companies, that have APIs usually exposes hundreds, if not thousands of different API endpoints. And each one of these endpoints has a different purpose. I want to talk about different types of APIs. You have B2B, which means business to business, B2C, which means business to client, and internal APIs. These are the main three categories of APIs that you can find today in modern companies. So the first type of APIs I want to talk about is the B2B API. So what happens recently, during COVID, the rental agencies in San Francisco is struggling to get more customers. So what they can do is to collaborate with the rental agency in Palo Alto. This is some type of B2B communication because we're talking about two different business partners. So the way to collaborate is basically the rental agency in Palo Alto would expose an API endpoint that allows the rental agency in San Francisco to get the email addresses of the richest customers in Palo Alto. And then the San Francisco rental agency can easily send like annoying email campaigns to these customers to tell them that they can buy a house in San Francisco for a good price. So this type of communication, this is B2B communication, because if you think about that, this endpoint of get/API/B2B/richest customers emails, it's not something that should be accessible by a regular client. It's something that you expose only to your clients. And also here in the response, you can see the email addresses inside an array. Another example for B2B API. So I'm not sure if you know, but I think it was about a year ago, Disney acquired Hulu. And let's say that Mickey Mouse browses Hulu and it sees that like the price of Star Wars, it's too low. It's only $5 and it doesn't like this fact. So what you can do is to use the B2B API that Hulu exposes to Disney as the parent company that allows them to set the movie price, and then it can increase the movie price to $1,000. So this is just a quick few examples for B2B APIs, and let's jump to B2C APIs. This is the most intuitive type of APIs to explain, because this is something that we use every day. Because we are the clients, we have mobile apps, we have web applications, and we use APIs every time that we access, modern applications. So there are three different types of B2C APIs. Some of them are mobile. So if you take a ride on Lyft, for example, once you click book ride, there would be an API call to post/book ride on the Lyft API. So this is a type of mobile API because it should be accessed by mobile clients like Android and iOS. And then you have the web API that is supposed to be exposed only to the web application. The web application means the website that you access using your browser. So I'm not sure if you know, but Lyft has a platform that if you are a company and you have employees who travel using Lyft, you can manage the employees on this platform, but they don't provide you a mobile application. You have to do it through the browser. And in this framework, basically in this Lyft for Business web application, you have an option to export all of your users. So once you click export users, there is an API call behind the scenes to the web API. By the way, just a quick trivia quiz. What would be the HTTP method if we access the export users endpoint? It would be probably get, because we just get something from the API. And last but not least, there is also the IoT API. So Lyft is actually a great company to explain about different types of APIs because they have so many types of clients. They have the mobile, they have the web, but they also have IoT. Like for example, in many cities in the US, Lyft has scooters, e-scooters. They are a lot of fun. They can also be annoying sometimes, especially in San Francisco. But what happens once you take a ride on the e-scooter on Lyft? Lyft needs to know what is the location of the e-scooter, right? It's their device. They don't want it to get stolen or to get lost. So what happens? There is a GPS inside the e-scooter that every few seconds sends an API call to the IoT API of Lyft that says update location of the device. And then it tells the API what is the current location of the e-scooter. The last type of API that I want to talk about is internal APIs. You can find it in Kubernetes. Behind the scenes, Kubernetes is driven by REST APIs. And also in microservices, many times you send an API call to an edge API. Behind the scenes, there are a bunch of API calls between internal microservices. And these internal API calls is usually REST API. So as you can see, modern concepts in the last few years, even the last 5 or 10 years, are heavily driven by APIs. When we talk about cloud providers, microservices, mobile applications, IoT, and Kubernetes, all of them are driven by APIs. So let's talk about the OWASP API top 10. The OWASP top 10 for APIs is a list that defines the top 10 threats for APIs. But before I jump into the list and talk about the project, I want to talk about what is the difference between traditional applications and modern APIs. So in the case of traditional applications, if we talk about HTML-based applications, you can find a bunch of traditional vulnerabilities like injections and cross-site scripting, CSRF, XXC, and so on. The thing is, those vulnerabilities are much less prevalent in APIs. There are many reasons for that. I'm not going to talk about it in this webinar, but this like cross-site scripting injections are not really a big threat in most of the APIs. But there is a completely new field of vulnerabilities that target APIs. And the reality is that I can tell you that as a pen tester and also a security engineer that reads a lot of in the news about recent breaches, that APIs are great targets for attackers. You can see every week a huge company gets breached because of their APIs. And also as a pen tester, many times the API is the best way to start like a security assessment because they tend to be the most vulnerable. There are a few different components that make, or a few different concepts that make API highly interesting for pen testers. And the main 3 reasons are, first of all, the attack surface is much larger. If we compare a dashboard, if we compare a specific feature, let's take, for example, the dashboard of a website, and we compare the dashboard of the website in a traditional app that is based on HTML, for example, like some ASPX app, where the server renders the HTML pages, and we compare it to the same feature, the same dashboard of a website, but this time we talk about a modern application that is driven by APIs. The reality is that the API exposes much more entry points to access the same exact feature. Behind the scenes, the communication looks very different. Instead of just one API call to the HTML page, you would perform a bunch of different API calls to populate different areas in the app itself. So every attacker that you would ask can tell you that the more entry points, the more parameters sent to an app, the larger the attack surface. So APIs basically expose more parameters, more endpoints, and it makes them more interesting and it makes the attack surface larger. The second point is that APIs are oversharing. Developers tend to return a lot of information from an API endpoint. And it allows attackers to many times just to get for free, like to leak data of other users just because of the way that developers build APIs. And the third point is that APIs are predictable. Because of basically the REST standard encourages developers to develop APIs and to expose them in a very generic way. So it's much easier for you as an attacker to find more endpoints. And for example, to find what are the admin endpoints of a specific API, just because of the REST standard. If we take a look at a few recent breaches in APIs, you can see that recently we had a breach in Uber. It was found by a security researcher. And what happened there is that the API was oversharing and it allowed full account takeover. It allowed you as an attacker to get full access to all the users on Uber, both drivers and riders. And it happened because of an API that overshared too much information. The second vulnerability was the famous Facebook breach. It allowed you to basically steal any user account using the view as feature on Facebook. And it also happened because of oversharing API. The Facebook API, by mistake, the developers exposed the authentication token of the other user. And then another example is the Shopify breach. It was found as part of a bug bounty. It happened because of a predictable admin API. It allowed the attacker to set himself as a shop manager or on any shop on Shopify, basically to get full access to any shop on Shopify. And all of these changes that we discussed in the last few slides made me join OWASP and start the OWASP Top 10 for APIs project together with Erez Ilon from Checkmarks. And this OWASP Top 10 for APIs list basically addresses the top 10 threats for APIs, with a big focus on authorization, authentication, and business logic abuse. I want to give you a few examples for breaches from the list. The first one, this is the most common attack on APIs. Broken object level authorization. This is a really big problem that you can find as a pen tester in almost every API. I usually say that the BOLA vulnerability, the broken object level authorization, it's like the new SQL injection. Because if you knew how to exploit SQL injections like 10 years ago, as a pen tester or as a hacker, you could probably get access to most websites over there. So BOLA is the same thing. If you know how to exploit BOLA today, you can probably take control on many different APIs to find very interesting vulnerabilities. BOLA is also known as IDOR. And now I'm going to talk about what happens when an API is vulnerable to BOLA. So basically, in a very high level, the problem is that the developers don't validate that the object requested by the user actually belongs to the user. So let's say that you have a ride-sharing app like Lyft, and then you have Bob, who is a legit user, and he just took a ride and he wants to get the receipt for the ride. So the API call would be get/receipts/number5, which is the ID of the ride that you just took. And the API would just return a PDF containing all the information about Bob, the source, the destination of the ride, and also the credit card, how he paid for this ride. So this is fine. But what happens if an attacker generates the exact same API call? In many cases, developers don't actually validate that receipt number 5 belongs to the requested user, and they would just return the attacker the same receipt they returned to Bob. And this way, the attacker can easily enumerate all the receipts in the API and to steal all the information of all the users who took ride. Let's jump to number 5 in the list, which is broken function level authorization. And this is also some type of access control or authorization problem, but here is a bit different because in this case, the API don't validate that the user belongs to the right rule or a group. So what happens, usually the impact of this thing is that attackers can access admin functions. They can access admin endpoints or endpoints that they shouldn't have access to because they don't have the right, they are not belong to the right group of users. So let's imagine that you have an API that exposes also admin functions. In this case, an admin can trigger an API call to get/admin/export all users and to get a list of all the users on the system. So this is an admin function. And this is fine because admin should have access to this endpoint, right? Admin should have access to get all the users. But what happens if an attacker generates the same exact API call to get/admin/export to users? In many cases, the APIs would not validate that the user is an actual admin. And by the way, if we compare it to BOLA, in this case, we don't have a specific ID that should be validated. Here we're talking about the group of the user. So if the API doesn't validate what is the group, it's vulnerable to BFLA, broken function level authorization. And last but not least, it's improper asset management. This is more like a housekeeping vulnerability, and it has two different aspects. First of all, you can find many APIs that exposes a bunch of endpoints, but some of them don't have documentation. And if an endpoint doesn't have a documentation, it means that nobody actually knows about it, right? Maybe a developer wrote it a few years ago when he left the company, but he left no documentation. So it would be really hard to know about this endpoint. So in this case, we have an API with three different endpoints, the v1 get user, update location, and then you have the export all users. The first two are documented. They're part of the documentation of the Open API spec. It's good and fine. But then the export all users doesn't have documentation. And this is a big deal because if you don't know about these endpoints, you can't even like protect them, right? And this type of this aspect of improper asset management should be done by developers. Developers should have the responsibility to document new API endpoints they expose to the internet, or even like in internal APIs. And the second part of this problem is unknown API hosts. You know, today in modern environments, it's almost too easy to do DevOps. If you want to spin up a new API, a new environment, it's just a few clicks on the AWS console or like the whatever cloud provider you use. Because it's so easy, it leads to a situation that many times companies have this like complete microservices or API hosts or even complete environment that they expose, but nobody actually knows what is the purpose of them. Like this is an example for an API that I saw. Like I did a pen test for a company and I asked them, what is the purpose of this QA-3-old? And they didn't really know what to tell me, even like the DevOps team. They didn't know what is the purpose of this API. And this API was actually vulnerable. So this is the second aspect of the problem. And this aspect should be addressed by DevOps that needs to document the different API hosts. Cool. I really hope you enjoyed the presentation. And now I'm going to hand it back to Dan.
Great. Thank you, Inon. There's a lot of great information. With that, we'll move on to the Q&A portion of this webinar. So we've got first question, I think related to a piece that you just covered. Is BOLA the same thing as IDOR? And if so, why the name change?
Yeah, it's a great question. And actually, Erez and I tried to come up with a new name for a long time. And we decided about BOLA. The reason why we didn't call it IDOR, we didn't want to leave the name IDOR, it's because IDOR is insecure direct object reference. And object reference is basically the ID, right? Object reference is an ID. And the problem with BOLA is not about the ID. The problem is that the developers don't check that's the authorization of the object. So we wanted to shift the attention from the ID, because developers use IDs and it's fine, to the actual problem, which is access control. And also, by the way, IDOR also covers a few different aspects that are less relevant to APIs. So for example, in the case of IDOR, it also includes like file access and some like other path manipulation stuff. And we didn't want to include it as part of BOLA because it's less relevant in the case of APIs.
Very interesting, thanks. Another question we have, someone says, I have an ngWAF installed on my network. Does that help protect me from these API attacks?
Yeah. So first of all, there are many types of ngWAFs, and I think today most of the WAF companies claim to be ngWAF. It depends what the WAF does, but usually this ngWAF and WAFs in general are blind to business logic vulnerabilities. they would be able to protect you against the more traditional attacks like SQL injection and cross-site scripting. But when it comes to API attacks that require a very subtle change in the traffic, in the case of, if we compare, for example, let's compare SQL injection and BOLA, right? In the case of SQL injection, the payload looks very malicious. You have like quotes and you have special characters and you have like a SQL statement. And it's very easy to kind of sign this type of payload and also to trigger alerts from the WAF perspective. But in the case of BOLA, it looks very different. You just change the ID from like 6 to 5. This is not something that the WAF or an NG-WAF can tell you that it's a malicious vulnerability. In order to solve this type of problem, we need much more sophisticated solution like Traceable.
Great, thanks for that. Another question, I'm familiar with OWASP top 10. Is that the same thing as the list you mentioned? I guess I'm in the OWASP API top 10.
Sure. So it's the same organization. It's the same open source organization. The OWASP top 10 for APIs is under OWASP. But the difference between the lists is that, first of all, the OWASP top 10 is both for client and server vulnerabilities. But when you talk about the OWASP top 10 for APIs, it's only for server vulnerabilities because APIs is the server, is not the client. And also the last release of the OWASP top 10 was in 2017. And you can find that this list is not very updated. Like the 2017, you can find things like cross-site scripting and the injections that become less and less prevalent in modern applications, especially in the last few years, because of new concepts in application development.
Great, thank you. And one last question we have, similar to the previous one, different technology, we've implemented RASP with our applications. Does that protect us from these API attacks?
I think I would answer it the same way. RASP is actually a cool technology, and in my previous companies I used to deploy RASP. If you manage to deploy it without breaking the production environment, it provides you pretty good visibility to like what vulnerabilities exist. But again, they focus. If you take a look at the RASP companies today, they focus mostly on injection and cross-site scripting. So they wouldn't be able to help you to protect, again, business logic vulnerabilities that are much more prevalent in the APIs.
All right, thanks for that. This concludes this webinar. Thank you for joining us. And as a parting gift, I'd like to make everyone aware of a new book on the practical guide to API security, written by our partners at Big Compass. On screen is a link to the book, so you can go get it now, or you can take a screenshot or the QR code. We'll also mail out this link if you're registered for the webinar, along with a pointer to the recording. Once again, thank you for your time and attention. Thank you, Inon, for your time and great presentation. Have a good rest of your day or evening.
Thank you very much. Bye, everyone.